So we'll go back to the etc. folder. And here we go to national code.
23.
33.
23.
23, okay. And we see here hook length. We'll open it. Okay. Bar diameters, anchorage value of hook. So this is like a matrix.
Okay.
Bar diameter equals.
I want to just ask the one simple question.
Yes.
You just go little bit up, little bit more, little bit more, little bit more. Now, here, line number 28,
Yes.
the hook value said is 96. So what will be 96 in Allplan?
Yes, I understand your question. You are referring how Allplan measures the rebar, right?
96, how they measure 96?
Yes, I know. I'll show you how. So basically, the Allplan has two ways of measuring the bar, and we can find this in the options. If we go to reinforcement options label, you will have here a description. So Allplan has two options. The default one is to add individual segments, so they only measure straight segments tangent to the curvature, or it has these options to calculate the actual length, and in this situation it will also calculate the curved ones. And if we go to see, so this option only affects the reinforcement bars that are created after choosing this option. So if I tick with actual length, only the bars that I will start creating will be affected by this setting. So if we look at the stirrup partial schema, we have here is the closed version. So this 7 is actually the length after the straight segment ends. So if we try to open the stirrup, or maybe like this, we'll see it better. So 54 is the straight part of the segment. Starting the arch and the last straight segment, it's the 7. So 7 covers this part. If we start measuring like this, we'll get 4 something centimeters, and the other 3 is on the curvature. So basically 54, it's the straight line. So if we draw a dimension line to see better this, okay, so we'll start from the straight segment. So let's see, 54, it's the tangent segment. So basically if I go with a line that is 54 in length, I should start the line. In this situation it's easier to see, it's from the tangent part. So from here, this is 54. So it measures, it can measure 3 dimensions. You have to choose before drawing the reinforcement, or you can change, but it's more complicated, you can change after you finish the reinforcement. So it's essential what you are choosing here in options reinforcement label. You will choose what segment should Allplan measure. So it can measure the exterior, the inner X or the middle X, or the interior, but it will only measure the straight segments. If we choose with real length, we are limited only to outer or axial dimensions. So basically, this is thing like this. This is the corner of a syrup, and this is how Allplan measures it. In reality, it is curved, so it's a chamfer between the perpendicular lines. But basically, he measures the big tangent segment. And I understand also from your drawing and the way you wanted to dimension. There's also this looks similar to the British standard, this type of detailing. You can also see in a list, maybe it's better understood if I place a list according to the British standard for the reinforcement we created yesterday. If you go to reinforcement for the English ones, so you need to reports English. You have British standard for all, and you will have some codes which maybe you are familiar if there are any similarities between the British code and the Indian standard.
Okay.
So that is the answer. So it's only tangent lines. Okay. We go further?
Oh, further, yeah.
Okay, so you can change that hook here. I found it. Replace it with 8, and it will be the hook length. So imagine you are drawing just a rectangle, and you start with the inclined line, and that will be 8 bar diameters. Okay, so further on, the important part, I'll also go through the email from last time because it was really good synthesized. So that modeling of continuous beam and also the detailing as attached per an example. I just had it open. If not, I'll just open it again. Okay, so we will do this type of reinforcement as you have it here. Okay?
Yeah.
I reinforced one beam and then adapt the reinforcement to the others. And we will discuss about the detailing multiplication. So basically, I will tell you what the issue is. There's a big difference in working beam in 3D and working in 2D. Normally in 2D, once you finish this drawing, you can do a copy and then extend the beam, do some stretches and the modification, and you just update the rebars, the marks, and the bending schedules, and it gives you the impression that it takes less time. The problem is you have little control over the 3D model, so once you get modification, you can get stuck with some errors, because if you are distracted while adapting this detailed beam to another, you might forget to replace some rebars. Anyways, there's another difference here. Here is not from, let's say, the producer's point of view, the German who designed the software. This is not a very detailed manner. We basically have here 5 rebars, but we do not understand exactly where they should be placed. So Allplan has no problem in creating 100% this type of 3D reinforcement. So we'll do it together exactly as in your drawing. And then we can adapt the 3D cage for all the other beams, no matter the span, and no matter if we need to change diameters per some of the sections. So there's absolutely no problem in doing the 3D part. However, in the detailing, you have 2 options. You either use Allplan with its automatic features, which give you more precision, meaning we can detail each bar with a circle, or we can use this open detailing where we can manually say which rebars are there. We can add this arrow, we can add any text we like, but it's not correlated with the 3D. We always have to measure and check. So I'll show you the way we should work, and everything is automatic and you get good precision and update in case of modifications. And then I'll show how we can work around and use the 2D features in order to get these exact descriptions. However, we are unable to take the detailing of one beam and apply it to another. This feature is available for Allplan Precast, and which now it's called Allplan Plan Bar. It is another software. It is let's say an adaptation of Allplan for factories, but the price is really big, and it's thought like this for precast industry, where you create a precast detailing of a part, you just place the parts and you adapt the detailing. So I'll show you what you can do with Allplan in order to have a good speed and an accuracy of detailing. So you'll get nice drawings correct and in a fast manner, but you will decide if it's really worth doing exactly this way of placing text or somehow find the closest in Allplan. We will start with reinforcing these bars. We have one fast option would be to import this WG and have transform all your reinforcement lines into rebar. That is one option. I will show you the second way, where we create from scratch all these rebars. So basically we will need these how do you call them, these floating bars on top? Do you have a name for them, or?
No, you continue.
Okay. So let's do this reinforcement of beam. So we will create a span. That's where, let me check. Okay, we have beams, it's okay. Okay, and then we just have.
Now can I hold one? Now you have reduced the height of the section.
Ah, okay,
View
okay. Yes.
you want to
Yes, it was one of your requests. So how I do is the following. I just say create section. I select the objects. I select the area where I look from, so the direction towards the circle. I just make one click here, one click diagonally, and this is basically a shortcut in doing a small rectangle. If I do another polygon, we'll get a cross section in that polygon. So I do 2 clicks in diagonally, then I hit escape. Then I place the result, and without doing anything from this point, it asks here from point. So without hitting escape or any other button, I can choose the beams that I like. So I'm creating now another polygon like this. One click here, and the other to define the diagonal of a rectangle that will contain what I detailed. And then escape. So this is how I do. And now I remember that you asked.
now again I want to increase the same. By mistake I have done it not proper.
Okay.
And I want to increase the section height.
Yes, it's really easy to do this. You just have to click on this yellow border, and you will see here you have some handles. So I just have to click on this handle and pull it down or upwards. So I can do it anytime.
Okay, thanks.
Okay, you're welcome. So it's quite easy to do this. Anything that is detailed here is actually within a yellow box. So if you see here, this is a box that contains whatever I detail. So basically, this is the, let's say, the main idea behind the associative views. You select the objects that you like to see. you select the direction of visualization, and then you define this 3D box in which you see elements. Any modification of this box, even from here, will affect the result. So basically this is how you control what you see. It's just a box. This is not plottable or printable, and if you don't like to see it anymore, you should just go to options and deactivate this section object, so you won't be able to see it anymore. But I recommend in keeping it, as you always would need to adapt. Also, you might encounter another problem. If the initial section was smaller and didn't contain some objects you created, you will have to add them to view, and that's all. So in some situation, if it was initially smaller, then you added a lot of elements or rebars, and you update it and stretch it, but you do not have the newly added element, you have to add it to the view. That's all. Okay, going further. I will create a section through one of the beams. I'll need this only for the placement part. Also, are you using this type of scale, so drawing type? You know what this do? It's something really important. I'll show you just like this. So in Allplan, when you define an element, you don't need to use hatch, pattern, or fill. You always have to choose reinforcement concrete or any materials that you like. What is the advantage? If I choose, instead of hatching, I choose a style like this one's reinforcement style, I can adapt to the drawing. So if this is not a formwork drawing, it's a reinforcement, I choose it to reinforcement, and I can remove the fill. So it's just the definitions that I can set how the reinforcements should look on each type of drawings that I create. So for instance, for a formwork, I can choose it to be darker, and for reinforcement to contain nothing. So in this way, you can work with architects, or even inside your own office, you can just choose the type of drawing you are creating. So there's no need to remove or add hatches. Okay, so this is how I remove the lines. Also, in this situation, you do not have a slab. Is it okay that if we add the slab? I would like to...
We want to add the slab also.
Okay, because it's quite important for my discussion. If I add the slab, I can show you how the materials merge together. So if it's poured concrete and they have both side area of concrete, the concrete will merge, the beam and the slab will merge, and we will get continuity of materials. So it will be a good detailing. So let's see slab. I think here, when you define the slab should be in between the floors, or no, when you created your building structure, I've seen that you use zero thickness slab. So I will adapt to your settings. I'm not going to change your style of working. So I'll just draw the slab, choose some other color. Okay, and let me check if it's on. Okay, it's not in the correct coordinates. I wanted to place it on another, let's say, where I'm detailing. So I'll use this 3.2 coordinate. I'll say here 3.2, the low part, and a thickness of 15, whatever. Okay, so now I added the slab. The slab also needs to have this tile area in order to interact with the concrete of the beam. And also I will add this exposed concrete so it will be transparent. Now I'm going back to the detailing, to this drawing. I don't have here the slab, as the slab is just newly created. So what I'll do is add this to the view. So I select the entire building and add it again, and now I can see the slab. the problem is the beam doesn't, okay, it has this style area, but in this section is actually a view, so it doesn't cut the material. If I place it here inside, so within the beam, I will get continuity of material, or I should get continuity of material if I keep it inside like this. Okay, let me see, but not all beams have this style area, so I will let it as it was. So you can see this polygon, this section polygon can be changed in any view and will affect. So this is actually the depthness of view. What I'm going to do is create this, apply this texture, this style area to all the architectural elements made of concrete, so we'll get good representation in our drawings, so we won't get any hatches. Okay, now going further, if I have to add the slab also to the cross section I just created, I can do this. So now I also have some slab, so in this situation I'll do the same trick of extending the view. So it was shorter, now I can see the beam with the slab. Okay.
How you can merge the slab with beam?
The only trick I did was this. I placed style area, reinforced concrete. For this one, it's the same. It's reinforced concrete. So this is how the program understands that they are poured together and they are only one entity. And if you see, if I go to a scale definition, I have hatches. If I go to formwork, I have a fill, and if I go to reinforcement, I have nothing, but they just merge together if they identified as the same material. Okay, further on, I will create first these bars, so these superior bars. I will place this. Is this? I think it's 1/3 or 1/4. How do you count?
1/3.
1/3. Okay. So I will do like last time. I will use some lines just to help me, some helping lines. So if this was 1/3, I can select the span, and then with this line, starting from this point, I'll paste the value and divide it by 3. So this is where I will end the bar. Also for here, I'll do the same procedure. I will choose here the opening, copy it with this button, and then paste it and divide it by 3. I don't need to create more than this because all the others will be just an adaptation. So these are some helping lines that will help me create the rebar as in your example. I will create the rebar or shape, freeform, and I can choose some hooks if I want to create this.
No, this is only marking purpose, not the hook.
Okay, so you use hooks or not? Straight bar?
No.
No hooks, okay. And it's feet 12. So I'll say 12 millimeters, and the concrete cover, I think 3 centimeters should be enough. Or 4 because I'll also have some stirrups. Okay. So this is one bar I create. And then I can place it and then adapt it to all the other spans. So I will use this option. Actually, I'm going to create the stirrup as I did yesterday, because I want to show you the other type of placement which is more precise and easier to use. We have V8 IC with some zones. I'm not going to show again the zoning, just place one stirrup, closed, V8, and have 3 centimeters. Okay. And then let's do the placements. Okay. I don't even care if the beam is shorter, and you'll see why. So, or higher. So you'll see how I work here. And I'll show you how fast I can adapt. Okay. Now, I would like to have the same stirrup, but it's impossible as some beams differ in height. What I'll do, I'm going to use the offset polyline as yesterday. Do an offset with the concrete cover that I agree, so I know where to limit my polygon. So this is why I'm doing this. Okay. So here it's no problem, it was just for testing. And how do I adapt the stirrups? I hold shift and click on a stirrup. Then I have this small handle in the mid of the span. Click on this piece and move it here. And this is how I adapt all the other stirrups. So basically it's important just to create the first shape, and then I can adapt it to all the other spans. And similarly I will do with the longitudinal reinforcement. So I'll only need to draw it once and then multiply and change the diameters of it. Okay, so now if we even hit F4, we'll see we have stirrups in accordance with the concrete cover for all the span. Okay. Why I did this at this stage was to have a simplified positioning of the rebar. So I will place the rebar now. Let's say place bar shape, click on the bar, go in this stirrup, and I will choose segment as method of placing. Click on this and then change the number of pieces. So if I go in one of your cross section, I'll see we have, I believe there are 12 on the corners, and in the middle you have 10, right? Or how is this reinforcing done? Hello? Can you hear me? So,
your voice.
What? Any problems? As far as I see here, there should be feet 12 in the corners and feet 10 as intermediate, or how can I understand the reinforcement? I go into section 1.
So then you just come to the section, longitudinal section.
Yes.
Left side on the first page. This is the through bar. 110 plus 212 is through, means throughout the bar. For the full length.
Yes, but for the intermediate I'm interested now.
The 216.
So if I go, I'm doing now this intermediate bar. At the end I will do the full bar. So I want for this is 216, I see, which is placed where? In the drawing it's missing. Is this lower?
Which is placed 18 here and 18 here.
Oh, okay, interesting. Yes, we can do it. There's no problem, but for the moment I'll say I have two bars and then change them so they are placed accordingly. I do not see it as my initial section is not creating there. It's here and the rebar is here, so this is why I cannot see it. It is properly placed. However, in order to see the bars, I will do this. I will just move. I can either move or create another, but if I move this box, I can see the bars I just created, and then I can adapt it. So if it's like
How you can move?
well,
How you have moved the section, Mark?
with the move function, that's all. So or how do I move now the bars or
Not section.
the section was moved here. So basically I will undo. This was the initial section.
Okay.
And in order to get here, I have two options. I either move it, so I just have hold here and say move, and I can move it here, or I could have extended it, that's all.
Okay.
Now I see what is here, and I will position the bar. One will be here, and one will be, I don't know, intermediate. So this was incorrect. It wasn't phi 12, it was phi 16. But this is no problem. I just hold the shift button, click on the bars, and now I can switch them to phi 16. That's all. And now I can place them differently to respect your drawing. So I can see move. And this is a big difference. If I select the bars, or if I select one longitudinal bar and say move, I'm moving both of them. If I'm selecting the move function first and then one bar, it will only move that bar. So it's really important in all.
Which function? Which function?
Move function. The move function
Move.
that you use in anything from 2D.
That will move the both the bar, na?
No, this is the difference. If I select one bar and say move, it will move both bars. However, if I have no function selected, I first select the function move and then select the bar, it will only move one rebar. So this is one trick in Allplan, and it's also available for copying. So if you copy an element, it's important if you first hit copy or if you first select the element. So you get different results according to what you actually need. So
Okay.
now I did this placement. One is here and one is here. We'll also place the long bar. So actually I think I can place the longer bars to obtain this type of anchorage and then place these intermediate ones. Because this is a different representation. So one bar is here and the other is low. So actually this is what I'm seeing here as well. Only that here we also see the extension of the bars. So now it's enough to create this upper parts for one element, and then we can adapt for all the other spans. So if I go here, I will say that this one exceeds, it's not okay. So I'll go with that function to do an offset with the concrete cover in order to know exactly where to finish the bar. And I shorten the bars or I move the bars, it's the same issue. I can either move on one end and shorten on the other, so I don't shorten the bar twice. Here, in order to avoid selecting the stirrup, I'll say stretch entities and filter by diameter phi 16, and I have to retreat it to this helping line. Also, I will move these bars, so I will be within the stirrup. So this is how I adapt this, and in the other situation is quite the same. So for here we have the same spacing. So I hit midpoint, and in this situation we have a larger spacing, so it will be measured copy the measurement, hit line, and here paste and divide by 3. So this is where I have to end with the bars. I copy them, select the midpoint, and here we don't have a midpoint. I will select this virtual point. Okay, and then do the same type of adaptation. So this is how we work. We just create the first bars. I hold this indicator so I know how far should I go. I hold here as well without clicking, hold further, and it will detect the intersection. You can see track line 0 with track line 90. I can mirror it and then solve the ending. And here I think I'll just mirror it for simplicity, not waste any more time. Mirror it again, and then remove the what is exceeding. Also, I remember there's a way of cutting the rebar, so please remind me to show you. There is a way, there's a sort of a trick, but it's easy to use, to cut a bar. So you draw a 20-meter bar and then cut it at the point you need. Is with placing some steel elements. With mechanical fixings, actually. You place the mechanical fixing, it splits the bar, and you delete the mechanical fixes, but you have the bar split. I'll show it. Okay. So we only have now the top additional reinforcement. I will now do the lower part. The top part is easy, and then the lower part. The top part, I see it has no overlapping in this situation. What is the maximum allowed length for transport in India?
Short beam 12 meter.
12 meter. 12 meter is also in Romania. So we go here, bar shape, freeform. It actually doesn't matter the concrete cover, as I'm going to place it considering the stirrup, so it will automatically adapt to its correct position, so it doesn't really matter where I draw it here, only the length of it. And I will pay some attention to this, the length of the hook, but I cannot find it in your drawing. How do I know how long is a hook here?
Half the depth.
Half, okay.
Half the depth of the beam.
Oh, okay, okay. That is clear, but half of, let's see here. I just do measurement here. Delta Y is interest, okay, 15. It will be bar shape. 15. I hold shift button in order to make sure the rebar is straight, so there's no chance of having it inclined. Okay, but it's some split. Some split is required. I think I'll let it split here. So I have 12 meters, and I can either change this overlapping or This is always dependent on the diameter. Say if 12 is 40 diameters, or you have more than 40 diameters, the overlap.
Okay. Okay, 48, okay.
Okay, so I leave the rebar here. Here's also in a superior part. I can accept this. So we'll leave it like this. Otherwise, we can do just like yesterday and change the length of each segment, overlapping and
Yeah.
obtaining. Okay, so I'll just hit escape. We have here 3 rebars. I'm just placing the description so we have some control over what we are doing. And now I have to place it, and the way I'm going to place it using the segment, just click here and mention the number of rebars. I think usually there are 3 rebars, but the one in the middle is 10, or how do you?
Middle is 10.
Middle is 10. So at first I will say I have 3 rebars, and I will change the diameter in the middle to be 10. But first I'll start with 3 rebars of 12. So it's 12, it's 3 rebars. I hit escape and escape again. You will see that now I have in red the next segment, because I need to place all the 3 segments of the top reinforcement. So I'm doing now the same thing. I just do a click here, mention 3, do 1 escape and another escape. We have red on this part. I hit click here, escape, escape. I will need to do some modifications, of course, because the one in the middle shouldn't be overlapped with this one. I will solve all issues quite fast. I will create more sections within the model. So it was a nice section, this one, but I have better control if I create whatever I need. Actually, the way I determine how many sections is just by lowering the partial schema. So in order to have some control here, I will start lowering the partial schema, so I know how many sections do I need. Okay. Now, I also see here that I have anchorage smaller. I would have preferred to go here with the anchorage, so I can solve this issue from the partial schema. I cannot extend the bar as it's already 12. Here is 12 also, but here we have shorter than 12 bars. So how I'm going to fix this issue is I say stretch entities, select from here to here the reinforcement, and then hold shift in order to maintain orthogonal. And now this is 12, this is 12, and this is something extra, but I changed so it ends in the column, not at the beam. So this is also how I adapt when working. Now I'm creating the sections wherever the bar changes. You will see that the first section is as big as the biggest element, which is the slab. So this is why when I first create my section, I see almost the whole building, because it sees the slab entirely. But you'll see it's no problem when it comes to detailing or adapting to have better representation. But the first stage is to obtain the first cage, the first full cage for one beam, and then we will adapt for all the others. To fix them, we'll just go like this. I say dimension view, and it will place the dimension views. I don't want those yet. Okay, so here I can work on the bars. So you see, all of them we have 3 bars that are 12. It's not what we need. We need the middle bar to be 10. How I do this is I select it and change it to 10. That's all. It's the same thing here. We have here some extra bar. I can make this one 10. I will move it here and then move this one somewhere properly. So it's quite free. This one is 10, this one remains 12, this one 12 as well. And here it's a similar situation. I place it. Okay. And on the lower side, I can either mirror the top bars, but it's not a good idea, as always the overlapping of the top bars is opposite to the overlapping of the lower bars, as the bending moment differs. So I will need to create all these bars. You want this hook, so you want to anchor within a beam, right? As in the example. Okay, this is how we'll do also. For this, I'll start a new reinforcement, bar shape, freeform. I will start from one end. It doesn't matter if we get some lower, higher bars. We will just change the position of them accordingly. I'll also lengthen. They are still fit 12 diameter. The lower, no, it's 16, and there are 4 bars, so I say 16. Hold shift and go here. Oh, I think it's more than, say, 3 and 3. And check where it does the spanning. It's actually doesn't matter in this situation. I would waste time if I try to guess the values or start measuring to see exactly where the beams. It's a waste of time. I'll show you how we can do it faster. So I leave the bars as they are. And then I will reposition them so they always get anchorage within a beam. I will make a clear wing of this, so I just hit delete of the partial schemas. And now I'm going to use the partial schema for the lower bars to be able to place them wherever I need. Okay, and now you have, I think, in the first situation, 1 overlap. Every time the beam changes height, you need to overlap there, which is normal. So I will also need more than 1 bar, but it's no problem. I can recycle these bars. So what I'm going to do now is place the bars, and then I will adapt. It's faster this way. So if I have them already placed, it will be faster from all points of view. So what I'm going to do is place within the stirrups and then reposition them. I say placement, place bars. It will be with the segment option. Then I select the rebar, then the lower part, and it's 4 pieces, I think. Yes, 4 pieces. So I'll just say 4. Okay. Escape. Escape, go to the next one. Place bar. With the segment, so it's faster. 4 pieces. Escape for the description. Escape again. And then use placement. Place bar. And we go here on this end. Segment again. Right click 4 pieces. Okay, now we have them placed. So we'll need to think about the anchorage, where we would need it. So first of all, I will need the anchorage to be somehow centered here. So I think we'll do like this. Go back to that offset polyline. I can also show you how we can place the buttons that we do frequently in a menu, so I don't have to run so much through them. It will be here, stretch entities. I pull this schema here, and I'll need again that offset option to have the concrete cover here. It's on the left side this time, and then retract this bar, and I have to add hooks. I'll say there are 35. So to add hooks, just right click and say modify hook, add, click on the ending and it's 30, click on this end, 90 degrees, 30, 35, whatever. So basically now we have them correctly shaped. They are not correctly positioned yet. Again, we have the same situation here, or no, here we will have it. So I will retreat this bar with the stretch function again, and do the same trick with this offsetted line. And here. Always hold the shift when you want to change the shape of bars, as you will need to keep them horizontal. Otherwise you get inclined bars which will affect the detailing and won't look nice. So holding shift is a sort of ortho like in AutoCAD. 0.3, 90 degrees, 0.3. Okay. And now it's just a matter of replacing the bars where we need them. We have here the concrete cover. I can either place them here, or more intuitively I can place them here. So it's pretty much the same thing. That's the biggest advantage of working in 3D. You always get the correct positions. So there's no way of doing really nice drawings but with mistakes. So if the 3D model is not 100% correct, it's impossible to get nice drawings. So in one section we will see the problem. Let's see, we have intermediate rebars. No, in this situation we don't have. In Romania we place, for starting 450 we place some 2 bars here. It doesn't matter. Okay, we have some extra here, and on the other side we'll also do it with rebar. And I would like to see it's V16, it's only one V16. Okay, I will start it from here somehow and then adapt it. No, I will just from the top and place a big hook on it. And we'll have some lenses around it. Okay.
That is already you have provided.
What?
That is already you have provided, this one.
This is...
Just
I didn't understand.
you have to just reshape it.
What? Or...
This is not required.
Okay. This is not always required, or... Okay. So, anyways, this is how we would create it, and whatever, place it here to finish the reinforcement. And it's only one. Okay. And then we just do one mirror, so we finished with all the rebars that are needed. So and then we'll go to the other problems. Okay. Of course, if we didn't place it, so this is why we placed it. There is something, okay, placed. I'll just add the bar, so I add everything I draw, so I make sure that all reinforcement appears in all sections. So I say add view, add to view, and select all the views. Okay. The section is not here, this is why I do not see that rebar. If I extend the section like this, I will see that extra rebar also. Okay, I'll leave it like this for now. And let's